On pages 2 and 3, we are going to acquire an in-depth understanding of the inverse sine function. And then hopefully by going through this process, you can start to understand where these 6 inverse trigonometric functions come from. Okay, so let's take a look here. The first thing we're going to do is graph f of x is equal to the sine of x over the interval from negative 2 pi to 2 pi. Okay, so notice here I'm talking about good old sine of x. This has nothing to do with the inverse function just yet. Okay, this particular course really does not review the graphs of trig functions, so you may have to jog your memory about what the sine of x looks like. So we're going to graph it out. I do have the unit circle available that can help you. If you look at the grid, remember that on the x-axis you have angles, and then on the y-axis you're just going to have numbers. Okay, hopefully you remember that if you plot sine of x, the graph is going to live between -1 and +1 on the y-axis. Okay, so on the y-axis I'm going to be going by 0.5 units for every tick mark. Okay, so what we're going to do here, and I'm going to revert back to the unit circle here. We're going to be graphing this function from -2 pi to 2 pi. So essentially we're going twice around the unit circle, and for every angle, remember your x coordinates are angles, for every angle the y value is going to be the sine value of that angle. Okay, so if you look at your particular angle, so for example, if you were looking at the angle pi over 6 and we're doing this in radians, you could do it in degrees in a similar fashion. But if you were dealing with the angle pi over 6, you would plot the sine of pi over 6, which happens to be the y coordinate, so it's going to be 1/2. Okay, so that's how this is going to work. Okay, if we look at our grid, the x-axis is broken up into intervals of pi over 4. Okay, because you see right here we have pi over 2, and then we have pi, but then there's a tick mark in between. So basically if you look at an interval of pi units, it's broken up into 4 pieces. So each one of these tick marks is representing pi over 4. Okay, so this would be pi over 4. This is going to be 2 pi over 4, which reduces to pi over 2. This is going to be 3 pi over 4. This is going to be 4 pi over 4, which reduces to pi. This is going to be 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and then 8 pi over 4, which reduces to 2 pi. Okay, so these are the multiples of pi over 4. You may be wondering where the pi over 6 multiples are and the pi over 3 multiples are. They're there. If we try to put them on the x-axis, it's going to get a little congested. Okay, so I'm just going to leave it like this. Okay, but you can plot them if you choose to. Okay, so here we go. Remember, on the negative x-axis, you're just going to have the same thing on the other side. Okay, so let's start plotting. So what I'm going to do here is I'm going to go to my unit circle. I'm going to start with an angle of 0 radians. Okay, so the sine of 0 is 0. Okay, so I'm going to go ahead and plot that point. And then the sine of pi over 4 is going to be the square root of 2 over 2. If you put that in the calculator, because you're going to need a decimal approximation, this is going to be 0.707. Okay, so I'll write that down. All right, so at pi over 4, you're going to plot the point 0.707. Okay, so you're just going to have to eyeball it. It's going to be, over half, it's going to be between 0.5 and 1. Okay, closer to 0.5. Okay, and then if you go to pi over 2, the sine of pi over 2 is exactly 1. So we can plot that. And then if we go to 3 pi over 4, its sine value is the square root of 2 over 2, which is 0.707. Okay, so it should be about right here. Okay, then we make it to pi. The sine of pi is 0. So we'll plot 0 as our y value. And then we just keep going. Okay, let's look at 5 pi over 4. So 5 pi over 4 is down here. So now we have a y coordinate of negative square root of 2 over 2. And that's going to be approximately negative 0.707. So you're just going to have to eyeball that. Again, it's going to be between negative 0.5 and negative 1, closer to negative 0.5. And then 3 pi over 2, the sine is negative 1 exactly. That's its y coordinate. Okay, so we're going to plot at 3 pi over 2. We're going to plot exactly negative 1. And then 7 pi over 4 is in the fourth quadrant. It is right here. Okay, its sine value or y coordinate is approximately negative 0.707. Okay, so I will plot that. And then finally, we make it back to 2 pi. Okay, 2 pi is coterminal with 0 radians, so the sine value here will be 0 as well. Okay, we connect the dots, and you see the sine wave. Okay, this is one sine wave. Remember, the period of sine is 2 pi radians. Okay, it takes 2 pi radians along the x-axis to complete one sine wave, and this is it. We still need to produce the graph between negative pi and 0, but remember, these trig functions are cyclic. They repeat. So I can just quickly fill in this left side here. Okay, it's just going to repeat. Okay, so I'm going to take a minute and put these values in, just repeating the graph here. Okay, so here will be another sine wave. All right, so here it is. Okay, we have two waves of sine of x. Okay, and again, like I said, our goal is to see where the inverse sine function comes from. Okay, all right, underneath the graph, there is a question. Do you think this function f of x, which is equal to the sine of x, has an inverse? Okay, well, what did we say when we looked at the properties of inverse functions? Okay, we said that for a function to have an inverse function, it has to be 1-to-1. To be 1-to-1, the function would have to pass the horizontal line test. Okay, when we look at the sine function, okay, I can easily draw a horizontal line somewhere that hits my graph in more than one spot. Okay, so as it is, what we see here, the sine function in its entirety is not 1-to-1. It violates the horizontal line test. Okay, so we're going to say the sine function over the interval negative 2 pi to 2 pi violates the horizontal line test. So it cannot have an inverse. Okay, well then if you scroll down, it says look at your calculator. Okay, there is a sine inverse button, so I will pull it up. Okay, so if you look at your calculator and you find the sine button, if you look above it in blue, you see sine inverse. Okay, and plus we're having a whole discussion about inverse trigonometric functions. There has to be an inverse. Well, how is this possible? Okay, go back to page 1. Okay, in the properties of a function and its inverse, look what I highlighted in yellow. Okay, and I told you when we were going through this that this yellow statement was going to be extremely important for trigonometric functions. It says if a function is not 1-to-1, it may be possible to restrict its domain in some suitable manner so that the restricted function is 1 to 1. Okay, so what that means, okay, what we can do, or what is done mathematically, is that we restrict the domain. Okay, so the domain of this function needs to be restricted. Okay, a suitable portion of the sine function needs to be chosen, a portion that does pass the horizontal line test. Okay, and then from that we can create the inverse sine function. Now, you can't just go to the graph up here and pick any portion of it that you want, okay? Mathematically, that has been chosen for us, okay? So what we're going to do is restrict the domain to the interval between negative pi over 2 and positive pi over 2. Okay, so I'm going to highlight this. Okay, give me a second to pull up a highlighter. Okay, so we're going to restrict the portion of the graph that we're looking at to be the portion between negative pi over 2 and positive pi over 2. So let me try to get this inside the box. Okay, so this yellow part, and you can see what's inside the yellow box. It's a very small portion of the sine curve, considering that the sine curve goes on forever in both directions, okay? But this part that's inside the yellow box does pass the horizontal line test. If you pretend moving that red line up and down, it's only going to intersect the blue graph in one spot. Okay, so that means this portion of the sine curve is going to be 1 to 1. It will be invertible. It will have an inverse. Okay, so let's continue on. Okay, we're going to try to come up with the graph of the inverse sine function. Okay, so like I said, we are restricting the domain of the sine curve to be specifically the points between negative pi over 2 and positive pi over 2 included. Okay, so what we're going to do is make a table of values. Okay, so if you read above the table's already set up for you. It says what points x, y are on the graph of g of x is equal to the sine of x for this new restricted domain. Okay, we are still making a table of values for sine x. Okay, we have not gotten to the inverse yet. Okay, so I'm going to populate this table. Okay, remember, it's going to go according to how the graph went. The x values are going to be angles, and then the y values are going to be the sine of that particular angle. Okay, so when I fill this in, we are restricting ourselves to the portion in the yellow box, so between negative pi over 2 and positive pi over 2. So my first x coordinate is going to be negative pi over 2, and I want to end at positive pi over 2. Okay, and then I need to fill in some angles in between. The more points you plot, the better your graph is going to look. You will have a much better idea of what it looks like. Okay, so what I'm going to do is basically go around the unit circle and grab these angles. Okay, so remember, negative pi over 2 is right here. Okay, this is negative pi over 2 because it's a negative angle. Okay, negative pi over 2 and 3 pi over 2 are coterminal. Okay, so if we keep going, okay, the next angle we're going to encounter is 5 pi over 3. That is coterminal with negative pi over 3. Okay, so that's what's going to go in the box. And then the next angle is going to be 7 pi over 4, which is coterminal with negative pi over 4. And then we've got 11 pi over 6. Negative pi over 6 is coterminal, so that's what's going to go in the box. And then we will have the angle 0. Don't forget about 0. And then we will start looking in quadrant 1. Okay, so if we go to quadrant 1, we're going to look at the positive angles. Okay, we're putting these guys in ascending order here. So we're first going to hit positive pi over 6, and then we're going to hit positive pi over 4, then positive pi over 3, and then lastly we'll make it to positive pi over 2. Okay, so that's what's going to go in the rest of the box. Has to go in this order. Again, the angles are in ascending order from smallest to biggest. Okay, the y coordinate is we're going to go back and fill that in. Okay, this is going to be the sine of each angle. For example, if I start here at negative pi over 2, that's the input. Negative pi over 2 is the input. The output, or the y value, is going to be the sine of negative pi over 2. Okay, so if I look at negative pi over 2, what is its sine? Well, the y coordinate. So it's going to be negative 1. Okay, so I'm going to do that for each of these. Okay, negative pi over 3, it's going to be negative square root of 3 over 2. And then for negative pi over 4, it's negative square root of 2 over 2. For negative pi over 6, it's negative 1/2. And then the sine of 0 is 0. And then for pi over 6, the sine of pi over 6 is positive 1/2. The sine of pi over 4 is the square root of 2 over 2. The sine of pi over 3 is the square root of 3 over 2. And then lastly, the sine of pi over 2 is 1. Okay? All right. So this table forms a whole bunch of xy pairs. They are on the graph of sine x. Okay? So let's continue on. Okay? At the top of page 3. What points then, xy, are going to be on the graph of h of x is equal to the sine inverse of x? Okay, go back to page 1. What is a major property of inverses? Right here, number 4. If xy is a point on the graph of the original function, then if you switch x and y, the point yx will be a point on the graph of the inverse function. Okay, so what we're going to do is we're going to take this table and we're going to flip the xy pairs. Okay, and then those will be points on the graph of sine inverse. Okay, so for example, if you look at this point right here, the x coordinate is negative pi over 2, the y value is negative 1. This is an ordered pair on the graph of sine x. Okay, so what's going to happen is if we switch x and y, it's going to switch to be this point, and this point is going to be on the graph of the sine inverse function. Okay, so when I go to my table, I'm going to flip this point to be negative 1, negative pi over 2. Okay, so now I'm going to fill in this chart simply by flip-flopping the x and y pairs from this table at the bottom of page 2. Okay, so give me a minute. Let's do it for negative pi over 3. So that will become the angle. Okay, and then the x coordinate will be negative square root of 3 over 2. Okay, and then I just keep doing this. Okay, I'm switching. Okay, so it's going to take a minute to fill all of this in. Okay, so you just keep going back and forth and you're switching the x and y values. Oops. All right, almost there. Oops, I totally put that wrong. Let's fix that. This should be square root of 3 over 2. And then positive 1 for here. Okay, so again, all I did to fill in this table at the top of page 3, okay, I went to the table at the bottom of page 2, okay? And I'm flip-flopping the X and Y values, okay? So you can see a huge difference already. When you're working with just the sine of X, your input is an angle and your output is just a number, okay? For the sine inverse function, your input is going to be a number and your output is going to be an angle. Okay, so it's quite different. Okay, so what we can do now is graph the inverse function because we have a table of values. We know several XY pairs that are on the graph. So we just need to plot them all, okay? And then we will have our graph. So if you look at what I have here, I have just plain axes, okay? We have to figure out how to label them. Okay, so let's start with the x-axis. Okay, your x values, like I said, are going to be numbers. They are numbers between -1 and +1. Okay, so what I'm going to do is I'm going to put a -1 here, and I'm going to kind of space it out because I don't want it to be all jumbled. So I'm going to go by 0.5 units here. Okay, and I'm just kind of eyeballing this, so it may come out jumbled after all, but I'm doing my best to make it as big as possible. Okay, so this will be 0.5, and then this will be +1. Okay, on the y-axis, we need to have angles. The smallest angle needs to be negative pi over 2, and the largest needs to be pi over 2. Okay, so I'm going to come down here, and I'm going to put negative pi over 2, and then the largest needs to be pi over 2. Okay, we know halfway in between is going to be pi over 4 and negative pi over 4. Okay, we have to figure out exactly where to place the pi over 6 and the pi over 3. And this is how you do it. Okay, look at the top here, the top part of the y-axis. We're going from 0 to pi over 2. Okay, I am going to ignore the pi over 4, and I'm going to break this yellow piece into 3 equal parts. Okay, I'm just eyeballing it again. Okay, 3 equal parts. Okay, so this first one is going to be pi over 6. This would be 2 pi over 6, which is pi over 3. And then this last one would be 3 pi over 6, which reduces to pi over 2. Okay, so that's how it's going to work. Okay, again, I'm just eyeballing here. This would be negative pi over 6. This is going to be negative pi over 3. And then it would match up with negative pi over 2. Okay, so this is kind of the spacing you want to use. Okay, and now what we're going to do is plot our points. We're going to go from left to right. And I will plot the graph in blue. And yay, one more point, 1 pi over 2. Okay, so here it is. Okay, I'm going to connect the dots. And this is the graph of h of x is equal to the sine inverse of x. Remember how sine of x repeats indefinitely in both directions? So you may be wondering if this inverse function repeats, and the answer is no. This is the entire inverse function. Okay, it does not repeat. It's an extremely tiny graph. Okay, so we can go ahead and write down the domain of this function. Okay, domain is going to be what x values does this graph exist between? Well, the leftmost x value is going to be -1. Okay, and that point is included because an input of -1 gives you an output of negative pi over 2. And then the rightmost, the biggest x value that this graph covers is +1. It is also included because if you plug in 1 to the inverse function, you're going to get pi over 2. Okay, so we do want to include both of these points. You can also write this using inequality notation that your x values are between -1 and +1 inclusive. Okay, either way to write the domain is acceptable. Okay, the range is going to say, you know, what y values does this graph exist between? So if you look at your y-axis, look at the lowest point on the y-axis and then the highest point. The lowest point right here, it has a y coordinate of negative pi over 2. Okay, and we are including that point. It is an output. Negative pi over 2 is the output to the input of negative 1. Okay, and then if we go to our highest point, the y coordinate there is going to be positive pi over 2. We do include pi over 2 as an output because it is the output when the input is 1. Okay, so your y values go between negative pi over 2 and positive pi over 2. Okay, we could also write it this way. Okay, using the inequality notation. Okay, if you went back, okay, to the sine function when it was restricted, okay, so if I look right here and I look just at the segment of the sine graph inside the yellow box, the restricted domain, okay, we can say for restricted sine that the domain, the x values, this graph exists between negative pi over 2 and positive pi over 2. And then for the range inside the box, the graph covers y values between negative 1 and positive 1. Okay, remember that other major property of inverses, the one in green, the domain of the original function is equal to the range of the inverse, and the range of the original function is equal to the domain of the inverse. Okay, so that's what's happened here. Okay, what's inside the yellow box is considered the original function. Okay, you see its domain and range, and now that if we look at the inverse function, the domain of the original has become the range of the inverse function, and vice versa. Okay, this domain of the inverse function from negative 1 to 1, it's the same thing as the range of the original function. Okay, so it's all tying together. All right, you should know this graph. Okay, you should know all 6 inverse trigonometric functions, their graphs, and their domains and their ranges. We will talk about those in a minute. Okay, it is a very tedious process to come up with each of them. Okay, because we would have to go through the process of drawing out the original function in its entirety, then restricting the domain, and then writing down the xy pairs, then switching them, then plotting. So it is a long process. Okay, so as soon as we finish with sine inverse, I am just going to present the graphs, domains, and ranges of all 6 inverse trigonometric functions. Okay. All right, so let's go ahead and wrap up sine inverse here. There is a formal definition of it, okay? And you're going to have to think of the other trigonometric inverse functions in the same way. Okay, it says definition, y equals sine inverse of x is the number in negative pi over 2 to pi over 2 inclusive, that interval, for which the sine of y is equal to x. Okay, and then let's see, it goes into more mathy stuff. It says the inverse sine function, which is y equals the sine inverse of x, receives as input a real number in the interval from negative 1 to 1, or x is between negative 1 and positive 1 inclusive, which is its domain, and outputs an angle or real number in the interval from negative pi over 2 to pi over 2 inclusive. Okay. So basically all that is saying, okay, is that the inverse function is very much opposite what we're used to. So when you look at just the sine function, think about how that works. You plug in an angle and your output is a number. And so now with the inverse function, your input is a number and your output is an angle. Okay, so make sure you remember that. Okay, I'll even write it down right here. With these inverse functions, the input is going to be a number and the output is going to be an angle. Okay, please remember that. Okay, I'll even put a big box around it. That's important. Okay, one more thing and then we will move on to the other inverse trigonometric functions. There is an alternate notation for sine inverse. You can also call it arcsine of x. Okay, the same is going to be true for the other trigonometric functions. Like, for example, if you see cosine inverse of x, it is also called arc cosine of x, or tangent inverse of x is also arctan of x. Okay, so if you see the arc, that is another way to indicate the inverse.